the result is going to be mu1, mu2, mu3, mu1. And the same denominator, mu2, and the same denominator, mu3. Okay? So you apply the softmax. It's going to be this one. It's going to be still like the n, entries, okay? But now, okay, because all the terms have become like exponential, right? So think about this, okay? No matter what your value of mu I is, all these terms are going to be positive, right? Because they become like e to the power of this some value, right? So all these terms will be positive. That's the first thing. The second thing is like, okay, every entry, this first one, the second one, the third one, okay, will be in the range of 0 to 1, right? Obviously, right? And the third thing that's also very important is that the sum of these three terms, if you add them up, is 1, right? Because they have the same denominator, right? You add them up, it happens to be the same as the denominator, which cancel each other to be 1, right? So that's why, okay, we use, this is an example that we can apply for like 3 classes, by the way. Okay? So the softmax, okay, is like the inverse link function that we use for like classifying like more than 2 classes. And by the way, to be honest, like if you consider 2 classes, the softmax will reduce automatically to be like a logistic function. By the way, you can try it yourself. Okay, so I'm not saying like softmax does not handle 2 classes, but if it's 2 classes, you just use a logistic function. Probably that's easily. Okay, that's easier. Okay, but if you use softmax for 2 classes, this thing automatically reduce to logistic function. Okay, and the regression that applies softmax is called softmax regression. Okay, so so softmax guarantee that we will get positive values that sum up to 1, as I already explained. Okay, in a softmax function, it's reduced to logistic function when k equal to 2. I already explained all this. As a side note, the softmax function has the same form as the Boltzmann distribution used in statistical mechanics, okay, which is very powerful branch of physics dealing with the probabilistic description of atomic and molecular systems. But if you are not into these areas, you don't need to worry about that. Because remember, the author of the textbook is like his field is in the quantum chemistry. Remember, so he is more into this area. Okay, so he especially point out this. Okay, out of his own expertise. Okay, so Boltzmann distribution. Okay, and softmax. Okay, has a parameter called temperature T that divides mu when T equal to infinite. The probability distribution become flat and all states are equally likely. Okay, when T is close to 0, only the most probable state gets populated. and softmax behaves like a max function. But this is, you probably don't need to worry about that because this is just a side, just like a additional knowledge, for atomic and molecular system, okay, in physics, okay. So the Boltzmann distribution, I mean, in Bayesian data analysis, we don't have to know that, okay. We only need to care about, what we only need to care about is the softmax, okay. So, yeah, so I think I'm running out of time because the next one is going to be a concrete example that use the softmax. You can imagine, okay, the example that we are going to use is still the Irish data set because Irish data set actually has 3 classes, right? Okay, so we could use it, okay, but I don't think we have enough time today. So we'll stop here today and continue on this multi-class classification, softmax regression topic. Not next week. Okay, remember next week I'll be out of town. Okay, so there's no class next week, but the week before, the week after next week, okay, we will continue the discussion here. Okay, so this is how many? We are. This is like 46. Okay, it's yeah, we still have like about 30 something slides. So next time we will finish this chapter and move on to the model comparison. But as I said, I'm not sure how much I can do, because we have only 2 lectures left. But anyway, okay, let's play it by ear. Okay, I will finish up the generalized linear model and then talk a little bit about model comparison next time, and then so the model comparison has like a little bit more than 1 lecture, because I know model comparison has like more than 100 slides, so obviously we cannot finish that chapter. So but anyway, yeah, just remember, okay, the homework 4 has been assigned, and the due date I believe is it's a next Friday. Okay, next Friday. So you should have plenty of time. Okay, I believe only one problem that we haven't covered. Okay, so next Wednesday we will cover the material that's useful for the last question that I assigned. All the other part of the homework 4, I mean, you should be able to do it now. Okay? So, any question? If no question, that's it for today. Okay? So I'll see you in 2 weeks. Okay? Okay. Thank you. Bye.